Hello friends. Today we are discussing about the lecture number 4, that is based upon armature reaction and compensation technique. Previous lectures we already discussed about the DC generator constructions, working and EMF equations. Then we will start today's lecture, that is your lecture number 4, armature reaction and the possible compensation technique. Friends, first see, we have to discuss the main field or main flux generation. Okay, at no load condition. No load conditions, one point you have to remember, this is the first condition. You have to remember no load condition is there, means armature flux is zero. But field flux is there. Suppose there is a two pole machines. That is, there is a north pole as well as a south pole. Then what is there? North pole to south pole, the magnetic lines will go. That we know. Okay. But due to this north pole to south pole, the magnetic lines will go. Then there is some existence of field flux. Okay. Then field flux is not equal to zero. As there is no armature, then armature flux equal to zero here. But here it is clearly mentioned that no load condition. If suppose there is an armature is kept across this north pole and south pole, if load is not connected, that means what will happen? The closed circuit will not completed by these connections. That's why what will happen? The armature flux is equal to zero. Only there is only the field flux. That is known as the main flux generation. Now come to the second point. You see the second point, that is flux under load conditions. Suppose there is the field windings are not there. Only the armature windings are there. Okay. And when the machine is loaded means what will happen? The load is connected to the armature. Okay. Then what will happen? The current across this armature, if suppose we are giving an external supply, the current is flowing across the armature. That means it will also flow the across the load. That's why due to the armature current, what will happen? We know that armature current, if there is an armature current and armature current is not equal to zero, then also the armature flux is not equal to zero. As the field is not there, the field flux is equal to zero. Now, this is the whole process. Means under load condition, the armature flux is not equal to zero. Okay, that indicates that due to the armature, current, suppose this is the armature current, then definitely if I will put the conductors, because we know that armature is having the slots. Slots means the empty space like this. Okay, here the slots are. If you will equally divided this armature, then suppose few of the parts of the conductors are the means inward current directions, and few of the parts the conductor is outward in current directions. That means current is in from this side, current is out from this side. And due to this, what will happen? The armature can generate its own magnetic field, and that armature, what it generates the own magnetic field. This is nothing but, that's why the phi A is not equal to G. Now the very important point, the third condition, so you will understand. As I already mentioned that there is a two pole machines we are considering. There is one a north pole, another south pole, and one we are putting the armature. Then what will happen? You see north to south, there is the magnetic lines will come like this, from left to right, right? And here now armature will come. Then armature also we are understand, we already derived in this condition too. The armature, if it is connected to the load, then what it is connected to the load, that means the armature current is there, and due to the armature current, armature is having some magnetic field or magnetic flux. The armature flux is known as is your denoted as phi. If your phi is not zero, that means it will affect the main field generated by north pole as well as south pole. Okay, and due to this, the magnetic flux generated by the field winding, that means by the pole, is affected. Okay, that is nothing but the armature reactions. Then we will go to the next slide for the better understanding. Now just see the figure, and here you just see here this is the north pole, this is the south pole. We can say that the north pole and the south pole is the field winding part, field winding. Okay, and you see here there is one circular position, and here the armature is kept. This is the circular is your nothing but your armature. Okay, now you see in the armature there is the conductors kept. You see the these are the circular parts are the slots. This is nothing but slots. Okay, now you see the conductor. If I will divide the conductor into two parts, this armature into two parts. Left hand side you just see there is a cross mark. Right hand side there is a dot mark. If we know that the cross mark indicates the inward current direction and the dot mark indicates the outward current direction. Okay. Now you see, we'll detailedly understand the current will flow from this position to it will go outside. Okay. Now you have to see the conditions. What is the armature reactions? You see, armature current induces armature flux. What we already discussed in the previous class. And here you see there is north pole and south pole. Means these are the main poles. Due to the main pole, the field flux is can be computed. Then you see if the complete operation under a load of condition, complete operation, you just see there is if the pole is there and armature is there, then the effect of armature flux, the effect of armature flux on main field flux, because main field flux is north to south. Then if armature will keep and will evaluate the flux, that is nothing but your will known as a armature reactions. And what is the effect of armature reaction? You see, armature reaction has two effects, okay, on the main field. Means what is the effects? It demagnetizes or weakens the main flux. Suppose main flux is going from this pole to this north to south, then if armature flux will come, it may weaken because it is the center part. Then what the field it can be reduced by using this armature. Then another part it cross magnetizes and distorts the main field. That means suppose the field path it will distorts. Okay, maybe some other directions it will go. And another part is the you see here the first demagnetize or weakens the main flux means the voltage it will affect. The voltage it will affect. That means the generated voltage is reduced. And here cross magnetize or distort the main field means what will happen? The spark it will create. Okay, these two are the effects of the armature reactions. For that reason, we have to understand properly the armature reactions and we have to compensate also these armature reactions. Now come to the third point. Before going to the detailed analysis of the armature reactions, few of the parts we have to understand. Just see here, initially what we discussed, there is no load conditions. That means load is not connected to the armature. Okay. Then no current flows through the armature. If load is not connected to the armature means no current will flow. But what will happen? North pole to south pole, the flux may be passed, but no current across this armature will flow. This is the no load condition what we already discussed. Now you see it is a two pole machines because there is two pole, north pole as well as south pole. Now you see if the line in between this, the line joining the centers of the north and south poles is known as your polar axis. That means if I will draw one line, the dotted line you see in the center of North Pole as well as South Pole, this is nothing but your polar axis. Or you can say this is a D axis, okay, or direct axis. Okay. Now come to the next point, that is the field excitation. When the field winding is excited, a magnetic field is established across the air gap of the machine. You see, suppose this is the field winding. North pole means it is, we are considering electromagnet. Okay, electromagnets, I will explain again what is the electromagnet. Now you see, the if the north pole is excited and south pole, north and south pole is excited, then magnetic lines will come from the north pole to south pole. That also we know. Then you have to understand a few terms. Okay. Now you see here the few terms. Already we know about the polar axis. Okay, that is nothing but d axis, or you can say that is your direct axis. Now come to the point, the GNA. GNA, it is mentioned here, that is your perpendicular to the starter field axis or quadrature axis. Or what is the full form of GNA? The full form of GNA is that is nothing but geometrical neutral axis. Okay. Then come to the point. GNA, geometrical neutral axis, means suppose polar axis is the horizontal direction, it is the polar axis. Then to the perpendicular axis, if this is the horizontal axis, that is the polar axis, perpendicular to the horizontal axis, that is nothing but your GNA or geometrical neutral axis, or you can say that is an Q axis as it is mentioned. Or and Q axis means you can say this is a direct axis, Q axis means this is a quadrature axis. Okay. And you see there is another term is there, that is MNA. Okay, MNA means that is nothing but magnetic neutral axis. You can put here magnetic neutral axis. Okay, and you see another term, what is MNA? The axis through which no EMF is induced. When the armature is rotated, what will happen? Suppose north pole and south pole, when the armature is rotated, then if it is in vertical, okay, then what will happen? It will, the magnetic lines will cut the armature. If it is in horizontal like this, and you see the north pole is here and south pole is here, it is horizontal, the magnetic lines will pass, only the plus pass above the plates. Okay, it will not, if it is vertical it will cut, the magnetic lines will cut. If it is in horizontal it will easily pass between this. Okay, these are the concept. Then then we will see what is the effect of magnetic main flux, but due to the armature flux, we have to study the main fluxes. Okay, that is the case one. First case we have to understand. Only there is a field winding, no armature winding is there. Okay, now you see before going to this, only I am drawing the diagram, you just understand here. First case number one. Before to read this one, case number one. You see. First, I am showing the an electromagnet concept. Suppose there is a metal piece or metal rod. Okay, it is a bar shape. Then what will happen? You will just do the rotation of the conductors. Rotation of the conductors like this, because you are rotating the conductor. Okay. Then our our conductor is having two terminal. There is one terminal here, another terminal it is here. Now you just put one source. It is maybe AC source. Okay, and we can say now the current I will send from this side, left hand side. This is the plus or minus. The current is entering from this side, and the current is flowing across the across this wire, and it will come outside, right? Now you see, this is nothing but suppose the field current I am giving. Okay. Now you see, we now come to the understand the right hand thumb rule. Now see, right hand thumb rule is this one. Okay. Now thumb indicates the, suppose thumb indicates the current directions. Then what will happen? The call finger indicates, the call fingers indicates the magnetic uh, lines. If your thumb indicates the magnetic field, the call finger indicates the current directions. Now you put your call finger across this magnet, then what will happen? You see the call finger, if I will put, the current will be the like this. Current is coming outside, then it is going. Then you see the thumb is your right hand side. If thumb is your right hand side, you see the thumb is your right hand side means from left side to right hand side the magnetic lines will flow. If the magnetic lines will flow from this point to this point, okay, left to right, and we know that where to where the magnetic lines will go, that is your north pole to south pole. Therefore this terminal we can consider as a north pole, and this terminal we can consider as a south pole, right? And you see here the current is going towards in, and here the current is going towards out. That means if like this, then in this case also, in the generator case, same concept we can apply. Now come to the point. The same thing I will explain here. This is the electromagnetic concept, and the electromagnetic concept we that is nothing but it is a electromagnet. Okay. Now come to the point, we will discuss about your case one. Case one means we can understand that case one, that is, you can consider only the main flux. Main flux is there, no armature. Okay. Then here you just draw the circuit diagram by which you can understand. Suppose there is two plates or two things are there. Okay. Now the same manner you just rotate the conductors like this. These are the conductors. Where, because this is the metal, then we are rotating the conductors. Okay, the conductor is rotating like this. Okay, now you see we are giving the input current. This is the input we are providing. Okay, now this is the, because we have to connect the when winding in a series, you see this is the series connection. You see this is the current, then it will go from here to here. Okay, now this is the how, means your current is going towards in here. You see the current is going towards in, then the current directions are like this, then current is going in this path, then again the current is flowing. This is the outlet, right? Then suppose we are considering this is your field current, then definitely this is your supply voltage, the field voltage is there by which the current is entering to this circuit. Okay, now as per this concept, what will happen? Your current is going towards inside, that means it will behave as a north. Okay, now here you just see the current is entering, that means current is coming outside here. Okay, that is nothing but it will behave as a south pole. And as per the concept magnetic properties, that from the north pole to south pole the magnetic lines will go. That means from this north pole to south pole the magnetic lines will go from this point to this point. Okay, and you see the magnetic lines will go means there is a field is created, and this is the field is created. And due to this field, what will happen? You can tell as that is the field flux is developed. That when the main flux is only there and there is no armature, then there is only field flux is there. Okay, and we can say in case number one, the field flux is not equal to 0, and but your armature flux is equal to 0, because we are only having the, and what is this? This is nothing but your field winding, the same as generator case. This is nothing but your field winding. But if you will see that there is no armature, means the armature flux is 0. This is the same concept what we explained here. Now come to the next slide. Then we have to understand the case number 2. In this case, what we will understand? We will understand only the 2 point, that is, here the field winding is not there. There is only the armature winding is there. Okay. You already we discussed this point. You see the call finger. If your call finger indicates the current, okay, then what will happen? This is the thumb indicates the field, magnetic field. Okay, if your thumb indicates the magnetic lines, then thumb indicates the current direction. That only you have to. Okay, now we will discuss about the condition number 2. You see here the condition number 2. That means here the field winding is not there. Means a field flux. You can say field flux is absent, is equal to 0. Only the armature conductors or armature flux is there. Armature flux is not 0. Means armature flux is there. Okay. Now you see there is an armature. Now we'll go up to the conductor number, condition number 2. Is the okay. And there is the detail analysis like the this is the your pole axis or d axis, and the vertical one is your, we can say, that is your nothing but your q axis, or you can say GNA, and where GNA and MNA initially in the same plane. Okay, now we keep some conductors, you see, and this is the armature. If q axis is the center or center lines, vertical center lines, suppose I will, because we know that armature is having the armature slots. These are the slots: 1, 2, 3, 4, 5, 6. Suppose 6 slots in the left hand side. In the right hand side also there is the 6 slots. I mean 1, 2, 3, 4, 5, and 6. Okay. Now you see that left hand side, as north pole is here, as we know that north pole is the left and the south pole is the right side. Suppose, but we are not considering this field. Okay, but you just keep assume that north pole is the left side and south pole is here. North pole means the current will enter from the left side and current will go outside. Then suppose we will mark the current like here, the current. If current will enter, then I will mark as a cross. And here, if there is a circle or there is an output path, I will mark it as a dot. You see, this is the dot. Okay, that means you see here the cross mark indicates the inward the current directions, and dot mark is the outward current directions, right? Now you again, you see, you have to apply the you have to calculate the flux directions, because this is the armature. Then what we will do, we will calculate the armature flux. How to calculate this armature flux? You see, suppose we will put this conductor. this cross conductor. This is the cross. That means current is inward. Now you put the your thumb like this. This is the thumb. Okay. Suppose your means right hand thumb rule. You just see, and here you just keep this thumb direction is the current, and this is the call finger indicates the magnetic lines or magnetic flux directions. Now you see if it is the inward current, this is the inward current direction because current is inward. That means if it is inward like this, what will happen? The magnetic lines will in the clockwise directions. Okay, if you will put the inward current directions, if your thumb, if you put here thumb, that means that is your inward current directions, then what will happen? The direction of the magnetic flux is the clockwise directions. Okay, now come to the dot. If you will put the thumb is your outward, then the call finger indicates the these directions, that is your anti-clockwise directions. Okay, and you can mention that is anti-clockwise, and this is your clockwise directions. Now come to this point. You see there is a cross mark. That means here the magnetic lines will go upward, means clockwise. Okay, and here it will go to the downward. That is your anti-clockwise. Here you can mention that it is nothing but your anti-clockwise, and this is your clockwise. Okay. Now suppose I will conductor here also. This conductor I will check. Then it is also the same direction, upward directions. And here it is the downward directions like this. Now you have to understand one thing. Now what I will do, I have to find out the summation of armature flux. How the summation of the armature flux you see here. You see, this is the left hand side, all the current directions are inward. That means if I will see that all the conductors will generate the magnetic field or magnetic lines of flux in the clockwise directions. If I will put a summation here, then you see here what we will do, I will draw the sum block. You see, and what is the direction? Clockwise. This is your clockwise directions. Okay, and the current will means this is the closed loop path. Now come to this point here, the right hand side, you see if all the conductors are the outward, that means the current will go, means the magnetic lines will go anti-clockwise. If I will put the summation here, you see, then your current is here, the current is your, the magnetic lines will your downward, and it will go like in anti-clockwise. If you see how the total flux direction, you see there is one is clockwise and another anti-clockwise. You see in between this there is two flux in the same direction it is coming. But here it is opposite direction. But you see here inside this armature there is in the same directions. Then can I say if it will go downward, it is also coming downward. The resultant flux of this one is your downward. You can say the armature flux is downward. But what happened across this condition number one? Condition number one, North Pole and South Pole is there. There is an phi f, and what is the direction of phi f? Phi f is the horizontal, means left to right. If I will draw here, this is your phi f horizontal line. Then what is your? This is your phi a. Phi a is your vertical line. Means this is due to the field winding, and this is due to the armature winding. Okay, and what is this? You just see here the we have to find out the condition number 3 when both field flux as well as armature flux is there. You have to find out the resultant flux. How to find out the resultant flux? Resultant flux is nothing but you draw one line, the maximum armature flux, and this is your maximum field flux. Then one center line it will come, and this is your zero. Then what you will do, by connecting these two, you will draw one line. This is nothing but your resultant flux. And what is the resultant flux? That is your Fr equal to F phi F square plus F phi A square whole root over. But the point you have to understand here, that when both the field flux as well as the armature flux is there, then only there is another flux is developed or resultant flux is developed. That also we have to understand what is the resultant flux. Then that's why we have to go to the condition number 3 that we will discuss in next slide. Okay, this is our